You can also from here get a picture of kind of how crowded it is. There's so much equipment. Everybody brings stuff up. I brought a spectrometer that I wasn't able to use. I'll tell you about it. We did that at the University of Virginia. So I left the spectrometer up there. I left the video camera. So there have been about, I don't know, a couple of hundred people up there. I think in total there have been 450 human beings that have orbited the Earth. So you see, everybody leaves equipment, and it adds up. Yeah.
What was different in your experience in weightlessness versus training that maybe you didn't expect or anticipate?
It was just the steadiness of it. You know, in the plane, you could kind of feel, you know, you really never had a constant, you know, zero G. It was plus and minus, and even though you could float, you go up, you go down. It's here it was constant, and that apparently is what brings on the motion sickness with people. It's your vestibular system. You know, it's searching for an orientation which it normally has by gravity. By the way, if you look at the inner ear, it's marvelous. There are 3 perpendicular axes, yaw, roll, and pitch. And nature figured this out, you know, a million years ago, and we just did 100 years ago. It's just mind-boggling. But one of the things they have these fibers that, you know, when you nod off, they sense by gravity, hey, my head is not erect like it should be. You know, it sends adrenaline or whatever, and you know, whack your head up. And it doesn't have that in space, so that's one of the adjustments it has to make. But it's really a great feeling. Here's the view looking out of the station. I took with that camera I showed you. We're on the station now. That's Earth coming up, and you see the blue sky. You all know the blue light scatters the most. Red least. In space, there's no air to scatter anything. That's why it's black. And here's a Soyuz docked to the station. There are about 30 kilowatts of installed solar power now on the station. The plan is to be 100. One of the reasons why there's a lot of pressure to get the shuttle flying again is there's lots of equipment on the ground down at Kennedy waiting to be launched up. And I mean, the shuttle is a big vehicle. It can haul 30 tons. Soyuz can only do about 3 maximum. So it's always hard to compare the 2 vehicles. But the shuttle is needed if we're ever going to finish out the space station. Here's how you drink water in space. We'll show you some of the issues with fluids. I sometimes get asked, well, how do you take a shower in space? And the answer is you don't. That's why. We use wet wipes every morning, you know, to clean ourselves off. I was only in space for 10 days, so it didn't make a big difference for me. But imagine the guys who were there 6 months.
You brought the water up with you?
Yes, we do in 22-liter plastic bags. You know, we use water for drinking and also for as an oxygen supply. We use electrolysis and split it. We also condense water. The average human takes in about 2 liters of water every day. What I didn't realize is you exhale about 1.5 of those on the average. So there are 5 of us. That's like almost 2 gallons every day of water in the station. After a while, it would rain, so that's condensed out. You know, the air is recycled. We condense the water out. The water is actually purified. It's available for drinking, as well as the oxygen supply. We haven't had to use it yet because we bring up enough between the shuttle and the Soyuz. We bring up enough water that there's enough available for drinking.
So you bring the wastewater back in here?
No, it just it gets used up there. So
Used for what?
no, occasionally we do bring it down, and I'll show you at the end how, including food. I had heard a rumor that there wasn't enough food up on the station, and there wasn't enough of the good stuff. It's like anything else. If you've ever had to go over to a cabinet and say, you know, what are you going to eat? Everybody always pick their favorite food. So what happens is the beef stew and oatmeal and applesauce just, you know, really pile up. That's so much that we had to take it back and burn it.
Great. What happens if you drink alcohol?
One of my big disappointments was I didn't see any vodka up on the station.
You wonder what happens by nothing, or?
I didn't have any to you know, to answer the question, but I don't know. I don't mean like if you consumed a lot. Actually, other than the weightlessness, yeah, it would probably really tip you off that way. Room temperature, room pressure, sea level pressure, 760 millimeters of mercury pressure, and about 50% humidity. So it was a very comfortable environment. And here's how you eat in space. The Russians had a lot of canned goods, and we had a heat warmer, used the solar panels to power to heat it up. And that's it's a mixture of meat, rice, and vegetables. That's Cosmonaut Sergei Krikalev. He holds the record in space, 803 days.
That's a whole new experience.
What's his longest stay?
10 months in one continuous. He's been on the Mir, on the shuttle, and on the ISS, so he's probably the most experienced space person now.
Wait, spoon.
Sorry?
So the spoon will disappear.
Oh, yeah. When you're done with the spoon, when you put it down here, you can't just lay it down. We have a rubber band across it, and you have to put it under, because otherwise it would throw away. The foods, they don't use toothpaste foods anymore, and we didn't have any astronaut ice cream.
Aww.
Mostly either canned goods or dehydrated foods. And I thought the NASA shrimp cocktails were good. That was my favorite. They were dried shrimp and tomato sauce, and you injected hot water into it, reconstituted. I'll tell you, I've had worse shrimp cocktails in restaurants. But all in all, it was kind of like backpacking food. In fact, the NASA food is the same stuff they give the troops in Iraq for rations. This is a video of me sending an email. Believe it or not, we had email service via the Tejas satellite. And I didn't have my feet hooked under the foot straps, so it just got to float. We also had an IP phone. The thing to remember is that I'm still falling at 32 feet per second squared into the Earth, but that 17,000 miles an hour is what's keeping me in orbit. And here's a view looking of me coming out this way. It's really easy to traverse the station. The hard part is stopping. And I mean, that took a fair amount of muscle strength to grab on, and you've got to transfer your momentum back to the station. The other thing is, you see, typically